So some time ago, I came up with a basically a smart wheel setup to try to simulate the behavior of a cartwheel, like on a shopping cart. So I was able to actually do it in Blender as well. It's not quite the same as it was in Maya. In many ways, it's slightly more involved, but the final result actually is more animation friendly in some ways, specifically in that when I snap it back to its default position, it automatically resets everything to its default orientation and everything, which I could not get to work with the Maya version unless I basically did two things. I had to zero it out on the translation, and then I had to go to the specific aim target and set it to zero. But this one automatically goes back to zero just by snapping basically the root of the setup back to zero. So let's see how I did it. Okay, so to begin with, you want to basically have the model of your wheel. You at least need the wheel and a location for it to pivot from. And the place it's going to pivot from basically is this little peg here, the center of that. Okay, so next thing you're going to need to do is select your geometry, and I'd say just grab any edge that goes all the way around it and Shift D to duplicate it and then scale it out. And this is going to serve as essentially the ring that's going to guide your aim target that's going to basically aim your wheel. Okay, so once you have that, put it in the position you want it in. While you still have that edge selected, go to separate, separate selection, and then go back to object mode, select that curve you just brought out, and edit it, select all of the edges, and fill it in, because we're going to need that to be a full surface. Unfortunately, it doesn't work with just the edge, so we need a full surface. But once you have that surface, you can, while you have the object selected, you can go into the object setting, go down to viewport display for that object, and disable cast shadows, set it to display as, you could do wire, that'll work. And then make sure you go to the visibility settings and make sure it's not available in renders. And everything should be fine. Make sure it's not a shadow catcher or hold dot or anything like that, so it doesn't interfere with any renders. And so essentially that's going to serve as our aim surface. So creating the armature is going to be fairly simple. Shift A, armature, and you want to create your bones. You want to scale your bones so that they're pretty much visible. Go to the armature data over in your properties and bring it to the front so you can actually see it when you're working with it without having to go transparent or wireframe, anything like that. And you can also activate axes so you can see the orientation. We'll call us our wheel root. Okay, so now we need to create some bones. We need to create a bone for the wheel. So I'm going to Shift D on the root that I have. Oops, go to side view and Shift D. Bring it up and bring it straight up and align it with dead center of our tire. You can snap it just to make sure it's aligned dead center, or else we get some wobble, and we'll show it want some wobble. Shift D again. Bring it up for our pivot on our part pivot there. And we can go to transparent mode so we can see the wireframe. So when we're snapping, we can make sure it's snapping perfectly with our mesh. I have a edge right down the center, so it makes it easy. And then we need to duplicate one more time and bring it straight over. And this is going to be our aim that needs to basically align with relatively above the edge of our tire here, because we need to aim in that direction. And you want to go through and name each one of these uniquely so you know what everything is. So that's going to be my wheel pivot. So bone, and we'll give it our wheel piv or tire piv, whatever you want to call it. Okay, so now that we have our bones in place, we just need to set up the correct hierarchy. Now, in this case, we need our wheel to basically displace relative to the pivot of the cart pivot here. So we need it to follow that, but we also need this to follow a root. So we need to take our pivot, just select the root, Control P, and keep offset. Let's parent it with keeping offset, but we need our tire to follow the pivot. So select the tire pivot or the axle, and then just select our cart pivot, Control P, and keep offset. And that way our wheel will stay aligned relative to the rotation and location of our pivot there. Next, we need to actually take our animation guide geo here, and we need to basically take that and we want to skin it to the geometry here. So select the mesh, shift select the skeletal structure, and then Control P, automatic weights. And then you want to go in to your geo, and you can pretty much delete any other joints you may have in there or weighting groups, and just assign all weight to this one thing. And so it's easy to do that. Just with that one selected, you go into weighting mode. You can choose the vertex mode for weights, select all those, and then just assign, and it will assign all the weight to it. And so it should follow the rig now. Okay. Okay, so what we want to do is we want to add what's called a shrink wrap constraint. And go to shrink wrap, we'll bring that in here. Make sure it's specifying the correct object. In this case, it's actually going to be specifying our aim guide geo. Okay, and so it's constrained to that surface now. And we can do nearest point. We could do target and project. I'm going to leave it on point on surface right now, and that should be fine. I've tried some of the others and it usually snapped a little too much. Also, the reason why I left this as sort of an open plane without any sort of quads in it was because they were actually interfering with snapping and causing it to essentially lag a little bit and was aligning to the angle. So only having the outer edge with a filled face seemed to work the best for this one. Fortunately, it doesn't have to render or deform. It just has to sit there, so it shouldn't cause any problems. See if you can see it now. As you can see, our little joint is sort of just floating around on that surface. And that's exactly what we want. Okay, so now we need the pivot right here of our little cartwheel to basically aim at our main target, or our aim bone here. What did I call it? I called it the aim wheel. So we need basically the wheel to aim at that bone. So select that bone first, shift select the bone that's in your pivot here. And we're going to do Control Shift C on the keyboard. And that will bring up our aim constraints. But in this case, what it'll do is it'll use the selected objects to assign the target. Just saves us a little bit of time. And in this case, we're going to use locked track. You could use something like damp track, but locked track seems to work well enough, and I don't have to worry about it resetting. I don't have to worry about manually resetting it because damp track doesn't necessarily reset properly every time. But locked track does. So the one thing we need to make sure we do here is we need to make sure the orientation of our bones are consistent. So I believe the track axis is going to be the z-axis in this case, since all the bones are pointing straight up. And we can test that now just by grabbing our root. Okay, so now that we have our constraints in place, let's give it a test. And let's see, it's not aiming at it properly. Why is that? Let's see, let's check it. Okay, we need to make sure that the track axes and the locked axes are correct. Now, in this case, we need it to pivot around the y-axis. So let's set the locked axis as the y. There it goes. And the direction is a little bit wrong. See, it's flipping it around. So a little negative on the track axis. And now it looks like it's aiming in the correct direction. So you may need to toggled between those a little bit to make sure it's actually aiming correctly, which it now is. As you can see, it's tracking our aim target, which is here, our wheel aim over here properly. And so that's working fine now. And so that's most of the setup right there. The rest is pretty much just for the wheel. Okay, so go to your tire, delete everything in there except for wheel axle because you don't need anything else to affect it. Go to your skin weights, set it to vertex mode, clicking that little toggle up there, select all, and then assign weight 100, total 1. So it's full control over it. Then you can go back to object mode. So now we've got our tire, which should now spin relative to our axle bone here. So I'm going to rotate that on the X, and you can see that it's spinning. And it looks like it's a little off center. We'll get that later. Not sure why that's off center. But now for this specific kind of tire rotation, we want its rotation to be consistently moving forward because the tire is always going to flip around. And so we can just keep it moving forward relative to the direction, or the distance in this case, instead of the direction. Direction is going to be a little bit limited because if we start moving in different axes, then it won't necessarily rotate correctly. So I'm going to set my rotations to Euler value, the XYZ Euler, and we want the x-axis to drive our tire. So I'm going to right click on that. I'm going to say add driver. Oops, add driver. If you lose it, you can do edit driver over it. So you can go back into your expression like I keep doing. Okay, and so our first variable in this case needs to be the distance. Okay, and so we're going to switch this. I'm going to click where it says it has a default variable in here. We're going to switch it to distance. Okay, and then we need our objects to calculate the distance. Now, we actually need a couple of different things here. I'm going to come down here. I'm going to do go with the object mode really quick. Shift A, and I'm going to create an empty, or as it is called in Maya, a locator. You can actually create any object here. It could be a circle, a cube, or whatever, but I'm using an empty or a locator because it's basically not going to render. It's just empty object. And I'm going to scale it up just so it's easy for me to select it. And I'll rename it as my DST target. So my distance target. Then I need to go back into my rig, go back to pose mode, select my wheel, edit my driver, and okay. So now what do we need? I need one object. I'm going to choose my armature, and I think this is armature 1. Yes, it is. Armature 1, and my object is going to be the root. And basically, you want to choose whichever object you're going to use that's sitting relative to your locator. Whatever object you're going to use to basically drive the distance from the locator. So they should be overlapping ideally. So you could place the locator at the same location as your drive pivot. So it doesn't have to be the root, but I'm using the root. Okay, and then our other object is going to be our distance target. Okay, and this is so that when we move our rig, regardless of the direction, we go back into our expression here, that it will give us a value, see down here, based on the distance from this point to this point. Don't worry about this value yet. I still haven't done the calculation. Okay. So we've got the distance. Now we need to come up here and do a little more work. Let me see if I remember this expression correctly. So now we need to tell the expression to use that distance for something. So we're going to put in ABS, which stands for absolute, which means that when it looks at the value that it derives from the distance, regardless of whether it's positive or negative, it's always going to give us a positive value. And we're going to take that and we're going to multiply it times pi, or something close to pi. Anyway, I'm not going to do too many decimal points into pi. So we'll say 3.14. That should be enough. And we're going to divide that by the diameter of our tire, which is about 20 units. So make sure you measure your tire. And that should be it. We just press enter when that value goes in and we can test it. And everything spins. And the absolute value is keeping it spinning in the correct direction. Okay. And that mostly works. Now, if you need to make some fine tune things a bit when it comes to how quickly it's responding, you can pretty much just come in and just scale your disc here. Scale it out a little more, scale it in a little more. You can also play around with the setting. Let's try that. We wouldn't mean to say that. Okay. So let's bring that back here. Okay, and so now it's rotating, everything's pivoting correctly, and it looks like it's doing so at a good speed. Let me go from the top view, and so you have it aligned with pretty much pretty close to the edge of that tire, and that seems to be working rather well for it responding quickly. So just on the inside, or just about the diameter or radius of the tire from the center, seems to work really well.